In the name of Allah, the entirely merciful, the especially merciful. We've touched on albumin's antioxidant role, but this slide quantifies it, revealing a function of staggering importance. Albumin is not just an antioxidant, it is considered to be quantitatively the most important extracellular antioxidant in the entire body. To put this into perspective, it alone represents almost 3/4 total antioxidant capacity of our plasma. That's right, a single protein provides about 75% of the blood's ability to neutralize free radicals and combat oxidative stress. This reframes hypoalbuminemia from being just about osmotic pressure or transport. It represents a catastrophic collapse of the body's primary defense against oxidative damage, which is a key driver of organ failure and critical illness. Let's look at the two main mechanisms for albumin's antioxidant power. The first is one we're now familiar with, its powerful ligand-binding properties. A crucial example is its ability to bind and neutralize pro-oxidative metals, specifically copper, Cu++, and iron, Fe++. In their free, unbound form, these metals are highly dangerous. Here's the chemistry. Free iron and copper can interact with hydrogen peroxide, which is always present in low levels, through the Fenton reaction. This interaction generates hydroxyl radicals, which are among the most destructive and reactive free radicals in the body. By tightly binding these metals, albumin acts as a chelator, effectively putting them in handcuffs. This prevents them from participating in this reaction and stops the production of these damaging radicals. It's important to note that for copper, this is a team effort, as albumin works in conjunction with ceruloplasmin to ensure it is fully sequestered. The second mechanism is even more direct. Albumin doesn't just prevent damage indirectly, it actively sacrifices itself to neutralize threats. This function is centered on a single, unique amino acid, a cysteine residue at position 34, cis 34. In healthy young adults, 90 to 80% of albumin molecules have this cysteine sulfhydryl group, or thiol group, in its active, reduced form. This is known as mercaptalbumin. This free thiol group is a potent reducing agent. It acts as a primary scavenger, directly reacting with and neutralizing some of the most destructive radicals including the hydroxyl radical, hydrogen peroxide, and reactive nitrogen species like peroxynitrite. However, this comes at a cost. The presence of these reactive oxygen species, ROS, can induce irreversible structural damage to the albumin molecule itself, altering its function. In this way, albumin acts as a sacrificial shield, taking the hit to protect more vital tissues and enzymes from harm. We've seen how albumin directly scavenges radicals and chelates metals. Now, here is a third, proactive antioxidant strategy. Albumin is a crucial ligand for free fatty acids, specifically the polyunsaturated ones. These PUFAs are highly vulnerable to a process called lipid peroxidation, a chain reaction where free radicals steal electrons from the fatty acids, damaging them and generating more reactive oxygen species in the process. By binding these fatty acids, albumin acts as a stabilizing shield. It physically protects the vulnerable double bonds in PUFAs from being attacked by free radicals. In doing so, it performs a preemptive strike. It prevents the peroxidation process from even starting, thereby avoiding the generation of a whole new cascade of toxic lipid peroxides and reactive oxygen species. This is an elegant form of preventive antioxidant defense. Thank you.